Well, hello and welcome back to this episode 3 of SlimDevOps Live. Hopefully you can hear my voice. If you can't, if the chat would be good enough to let us know, I'm hoping this isn't a general audio problem and it's just the music playing up. But we've got an interesting episode ahead of us today, as Pieter has been working on an example that we're going to do a deep dive into. Excellent. Thank you, Eric. That's good that you can hear us. Hey there, Pieter. How you doing?
Good, good. Proud to be the official guinea pig here of trying to slim some containers live. Getting through my fear of live coding, so I'll admit that to the chat now. So stick with me, but I'm excited for it. I'm excited to walk through this one. So.
Excellent. I'm looking forward to it as well. I think there's a few tips here that people are going to be looking to pick up from our conversations in past live streams. I think there's going to be some details here that people are looking for. And before we dive into it, I just let Eric know, as he's here in the chat, we have made good progress running a Shiny app in a slimmed container. In that we have it working, so we will soon be sharing more of that with you, Eric, so you can help validate our results, and we'll be featuring R and Shiny in a bit more detail in an upcoming episode. So thanks, Eric, for setting us down that path. We've learned loads, and we look forward to sharing that with you. Right. Well, with that, shall we get into it, Pieter? Where do you want me to start?
Sure. Yeah, we can start just on the article. So we've been trying to figure out what the format of this container of the week is, and yeah, we're definitely looking forward to that Shiny example. I know a lot of people have been working on that one. This one's going to be incredibly simple relative to that, or some of the future looks that we'll do. But I think getting some of the format of like how we want to go through and do containers and look at them. Python Flask makes for a really nice, easy example. It's kind of like the hello world of, container slimming, because it's really set up well to do it. And it's like super easy to write Flask in. It's so simple, even I can do it. So, that's the example that we'll walk through today. Basically, we're just going to do a really simple thing. We're going to write a very simple Flask app. It's already written. I won't go through the writing of it because it really is just like 8 lines of code to do that. But that's going to be a very basic API that all it does is return a success message. And then we're going to build that into a Docker container. We're going to check out some things about that Docker container using a quick preview of the Slim web developer portal, the Slim developer platform's web portal. And then we're going to go through and use DockerSlim to slim that example. And, we'll retest it again, make sure that that's working. And then we're going to use the SNCC security scanner to go through and test it for vulnerabilities and stuff like that. And that's kind of like a basic format of, I think last time on the show, we were talking about like why you wouldn't like just kind of like slim a base image, or slim like just like if you just grab the Python image or whatever and slimming that, because it doesn't really do anything. And DockerSlim doesn't really know what to do with it. But like when you have a very simple app, DockerSlim can kind of probe the app, see what's happening inside of it, and then make some decisions about slimming it, and your success. Right. The chances for success are better. So,
and I see Eric in the chat, who is otherwise known as R Podcast, because he is the presenter for the R Podcast, talked about the Python Flask examples in the DockerSlim GitHub repo being his inspiration for creating a slimmed Shiny app. And Eric, it is no coincidence that we've gone back to Python Flask to sort of set the scene as we march down into sort of more, let's say, interesting examples with other language ecosystems. And Big Pod was asking, so what is Flask? And Flask is a mini framework for developing web apps in Python.
Yep. So yeah, Flask is similar. If you've heard of Django, Django's a little bit more robust. Flask is easy to learn. It was the first web framework I ever learned. It's very native to Python, and it's really good. I don't think people use it as much for kind of like full-scale web development anymore, but people do use it a lot for things like APIs or little microservices. It's really good at kind of like doing kind of call and response JSON objects and stuff like that. And that's what we're going to use it for today. So yeah, good questions. And yeah, you'll see a lot of coincidences between, maybe not coincidences between this one and the DockerSlim example. I definitely riffed off of what Kyle had put out there. Kyle's is a little more robust. If you check out the example at the DockerSlim repo, he has a lot of good like build scripts and kind of a robust make file there. I no pun intended, slimmed it down a little bit. I sort of simplified it a bit just for the sake of the walkthrough. So
brilliant.
Cool.
Okay.
So let's jump in. So we have a Git repo up for this, so you'll be able to find that. We'll put it in the show notes, or we'll shoot it out on our Twitter feed later. I think we also have a blog post up at Slim.AI that points to this repo, but so people can check it out. I also just kind of highlighted some of the results that we got out of it. So these are some of the things that we're going to look into, you know, the size of the image, what the improvement was, vulnerabilities, and kind of build times. Hopefully we don't have to do too much on build times. I'm not going to push anything to Docker Hub in this example, but so super simple. We're just going to build a really, really simple app. You know, in kind of all Python Flask development, you put things in kind of this little app directory. We have a small app.py, and then requirements.txt is going to be where we store all of our dependencies. Like I said, the app is 8 lines of code. We basically use Flask JSONify shortcut to create just a little, and the only thing that this thing does is it just, if it's successful, it returns a message that says success, and if it fails, it doesn't do anything. So that's like the extent of our app. So we won't spend a ton of time talking about that, but we just want something that can exist on an HTTP port that DockerSlim can hit. And while it's doing that, it sort of sees what's going on inside the image. And then that's what it does to kind of do the minifications that it's doing. One thing that's kind of that will throw people who use Flask a lot when you're going to use Docker for the first time is that almost everybody always uses 127.0.0.1 to do all of their local development in Flask. But when you're actually like putting this into a container, you need to actually use the host 0.0.0.0. I'm not exactly sure why that is. Maybe people who know a little bit more about kind of port forwarding. It binds
to all interfaces.
Okay. So, yeah. So you need to make sure you do that. That's something that wouldn't be sort of expected for a lot of people who are just kind of like picking up, you know, work with Flask a lot, but just like Dockerize their Flask app. So that's the main thing. The other thing that I did in this example was, rather than just doing kind of like the pip freeze requirements.txt to get kind of everything in my environment, I just made a very simple requirements.txt that only uses Flask. So I'm not picking up kind of all of the junk that's in my virtual environment, or if you're reusing virtual environments or something like that. So cool. So I'm starting with the base Python image. I had a lot of choices there. Obviously, you know, I could have gone with the Ubuntu image, I could use the Alpine image. You know, I could have found a Flask Python image specifically. There are a couple good ones out there, but I went with just the Python one because I think a lot of people do that. One thing that's kind of cool that I can show off is this is a little bit of a preview of our Slim developer platform web portal. So this is what we're working on and our team's working on right now. And if you're interested in checking this out, let us know. We can shoot you over an invite to this, though we're not really in any kind of beta or anything yet. But what we're doing here is, if you can search like major registries, and this is going to be that sort of like, you know, really popular Python, you know, the official Docker Hub Python image that we're going to use to base our container off of. And if you look at this in the web portal, this is effectively like a web version of the DockerSlim X-ray command. Is a good way to think about it. It does more than the X-ray command, and the X-ray command has some certain things. That's a command line, but this is a web interface for that. So we can go in and look at a bunch of environment variables and what versions are available for this particular container. You know, so that's pretty interesting. We know, like, okay, that's the Python version, that's the pip version that we're using. And then we can actually like click into the Explorer tab and look at how exactly this base image is constructed and what's inside it, and sort of what's taking up a lot of, which layers are taking up a lot of kind of build time, or what's being built where. And that just really lets us kind of like explore through all of the different instructions and files that are being created. So it's not super relevant for what we're doing with this one, but just wanted to give it a chance to kind of give a quick preview of that and go through it. So,
yeah. And
cool.
I would just add that we're still working on this stuff, but as it becomes more widely useful, we will be inviting members of the community to come and give it a try out their apps and containers on it and provide their feedback. So this will be something that you can play with as well. And it's all sitting on top of DockerSlim.
Cool. Awesome. Okay, cool. So if we get into it, so I wrote just a really basic Docker file for this example. We're just really copying the app file over into the app. We're going to run our pip install on that requirements.txt file, and then expose the port 1300. I note in the example, there's nothing like special about port 1300. It's just like useful for this example. And it's honestly what Kyle used in the DockerSlim example. He may have had a good reason for it, but that's just if people are wondering like why 1300, that's why. And then we're using this entry point command, and do a little bit of exploration in the article I won't get into here, but just about entry point versus command and like why you would use one versus the other. So we can go ahead and get into building this image. So just to kind of show people where I am in the terminal. So I've got my app file, just a couple README files. Those are just me writing, but then I've got the same Docker file that we were just looking at. So I'm going to go ahead and build that file. I'm going to name it Container of the Week, COTW. That's what we're using for this. And I'll call it Python Flask. And then I'm going to hit dot because I'm in my local file here, and I'm going to hit build, and we'll go through and we'll start building. And this is Docker. This is, this isn't DockerSlim. This is just Docker going through and running, and a little bit of a scary pip error there, which I'm not going to think about too much right now. I don't think it's too big a deal, but hopefully it's not. And cool. So, okay. So now if we go through here and we say, okay, what images do I have? Now I've got my Container of the Week, Python Flask image. It built. It's all good to go. Okay, cool. It's 896 megabytes. So that's like a pretty big image. And now I can go ahead and run it, right? So I'm going to run it on port 1300. I'm going to just click over here for a second. Oops, sorry. Don't mind me. So I'm running this, and let me just pick up. I just want to make sure I'm getting the names right here. So, okay, cool. And I'll name this. So I'm naming the container something different than the image, right? So the image is going to create the container. If people are very new to Docker, that's something that takes a little doing to get going. And then this is actually the container name. So okay, I'm putting that in there. So now I'm going to run the image, and when I do like the flag with -d, that means that it's running. It's a daemon. So, okay, cool. That worked. All right. So if I do Docker PS, now I can see, okay, cool. I've got my Container of the Week Python Flask image. It's running on this entry point. This is where it's running, and this is the name of the container. So hopefully that makes sense to everybody. If I click over to the web browser, and I just, I'm just doing a super simple test. Obviously, like, we could curl this, we could, go through and do, like write a test for this, but I'm just using the web browser to test it. And I get my success message back, which is great. Okay, cool. I can reload that and see that I'm getting my success message. So that's really great. So that means that I'm hitting the container, it's running, it's fat, it's all good. Okay, cool. So now let's think about slimming it, right? So the first thing I'm going to do is I'm going to stop the container that is running, because I'm going to end up reusing that port again in a second. But if I go back to the article, I can kind of walk through. So if we think about success criteria, that's like a pretty common question that we're going to have. Like, what's the success criteria, right? So my success criteria is I want to make sure the image runs, right? I want to make sure I can still curl that URL, or I can hit that my API, and I get back all the same expected responses. And then I want to make sure that the image is smaller and more secure after I slim it, right? What's the point of slimming it if it's not smaller? And we'll walk through a little bit about like how you would look at security, or a couple ways you could think about security. So,
right.
So I won't go into so let's do this. So I'm going to clear out. So now I can start using DockerSlim, right? So if I do DockerSlim, there's a couple ways to use DockerSlim. You can use, kind of command line flags, but if you just type in DockerSlim, you can actually get a little bit of an interactive prompt. And I can start with the X-ray command. And I'll show you what that does. We won't go too deep into it, but I can grab this container of the week, Python Flask latest that I was using. Python Flask latest. Boom. Okay, so there's that 896 megabyte thing. And I do X-ray, and it's going to start inspecting that container. And I think one thing, Kyle didn't mention this when he was on last time, but I really wanted to ask him about it. He's added a bunch of like colors to the X-ray command, which I think are really fun. It just reads a lot better than previous. So I think it's really cool.
That's new in the latest release of DockerSlim, I believe.
Yeah. So yeah, super fun, and be curious to see what this looks like in everybody else's terminal. But so what it's doing, and there's a lot of output here for sure. Which is one of the reasons we were thinking about kind of the web interface. The product team's thinking about the web interface for this type of stuff. But here again, we're seeing those same layers and that layer construction that was happening. Now again, this is on my Flask version of this, not the base Python version of it. But it's given me a ton of information about the files, the sizes, like what's building when, all of that kind of stuff. In addition to port information and that. It's a lot to read through, and it's a lot to look at. But that's always a good first step to like kind of go through and okay, I'm gonna look at that. So now we can get into building, right? So we can do the same command, but we're still in the DockerSlim interactive prompt. And now we're going to build. And I think I actually built one of these already. So I'm not going to rebuild the same one that I built. I'm going to use the one that I just created, Python Flask latest. And okay, cool. So what's DockerSlim doing here, right? So DockerSlim it's spinning up the container. It's doing this HTTP probe prompt on the different exposed ports that we have, right? And it's saying like, okay, I'm going to go use those ports. I'm going to kind of see what's inside, what's happening inside the container. And then I'm going to make some decisions. And once I make some decisions, I'm going to be able to clear this out, go through and create a new image. And it's going to rename that image with a .slim ending extension on it, right? So, okay, so now this is a new image. And one thing I missed on that is it actually does give you a readout about the new file size. Here we can see it's 48 megabytes. So it's 19 times smaller than the one that we had created just using the base Python image, right? But so we kind of passed one piece of our success criteria, but the most important one is, does it run, right? So I'm going to do that same run command that I used before. And I'll name it, container of the week, container slim. And but this time I'm going to use the slim image. I'm going to run the slim image. And hopefully this works and I didn't mess up any ports, and I did not. So, right, so what's running now, if I go back and look at Docker PS, right? So now I'm running from the slim image. And it's running all in the same way. And so if I go back to my browser window, success metric message, yay, it worked. Otherwise it would have failed. Yes, I should put in more failure states. I should do try except catches. There's a lot of bad Python going on behind the scenes here, but but it's working. So
indeed.
Cool.
So
So,
before you move on, we've had a
yep.
couple of comments I just wanted to touch on. So in the chat, Eric was asking about our success criteria, and went on to add that he would be interested in seeing how Slim containers can be incorporated in like wrapper platforms that use containers as units in a larger product. And so I've replied in the chat that we have a concept called collections, which should address that need. And that's definitely something we'll come back to and cover in much more detail on another occasion. And I think that was the only thing that occurred to me so far.
Yeah, I guess the other thing I would say is we do get a lot of kind of automated usage of Docker Slim. So I think like in the Docker Slim Discord, there's usually a lot of kind of people asking questions or talking about the way they integrate Docker Slim into like test pipelines and CI/CD. And I mean, obviously from Slim.AI, you can expect to see a lot of stuff on that in the future. We don't have a ton right now. But if people are looking to kind of like roll your own instances using Docker Slim, I think like the Docker Slim Discord's a good place to get some insights on those types of approaches.
And
but yeah.
you know, Eric comments that it was quite the saving. I think your saving there was 19 times.
Yeah.
Eric, I think from memory, the starting container size for the Shiny app that we've been looking at was 1.5 gigabytes, and our initial slimmed container is 225, but we think it can go smaller. So that's where we currently are with that one.
Yeah, and if people got a chance to see, if you want to see a node, and hopefully we can get Kyle on to do it, or we can get his notes on. He actually in his DevX presentation walked through sort of all of the different slimming capabilities, including Docker Slim, multi-stage builds, starting with Alpine and all of that, and sort of went through how they all tie in together and the different results. So the results from that one were pretty cool. I thought that was really interesting. So
yeah, so if you want to see that video, you can go to our SlimDevOps on Twitter, and you'll find that's in our recent tweets. It's a 15-minute information dense but accessible video from Kyle, who's our CTO and creator of DockerSlim, who goes through overcoming a number of Docker gotchas and also using DockerSlim to get some great results.
Yeah, and we'll put up an example. We'll kind of get that example in a more accessible public forum as well, because I think the results were pretty cool. So cool. All right, so we talked about size. Let's talk about security. So I am just going to use the built-in Docker scan tool, which actually Martin and I were talking about this before we got on. It's actually Snyk, Snyk.io, who a lot of people have heard of. They're actually the ones who power the scan capability in Docker, and it'll give you a readout. It's a third-party integration, so I've already authorized it in this use case, but it's easy, it's free, or at least using it this way is free. They do have obviously like paid versions and stuff, but it's like a pretty simple way to do it. So I'm just going to go through just as ground myself a little bit on where my images are. Oh, okay. So here's another note. So if you are going to do use the Snyk tool, and if you ask me if it's Snyk or Sneak or Cynic, I have no idea. I'm not sure they know, but I think it's Snyk. I hear them say Snyk on their live coding versions, but you do need to have your image in a registry if you're going to use it. So you do need to push it up. So I've done this example already, and just so I'm not cheating here, you can see that my image sizes are all the same, but I've already pushed this up to my Docker Hub registry to do the scan. So, but those are the images that I'm going to need to use. The ones that I just created on my local desktop, I wouldn't be able to scan them because they're not up in the cloud. So first thing I'm going to do is scan the first one. This was a reminder. This is the fat image, the almost 900 megabyte image. And I'm going to hit that, and we're all going to have some nice, pleasant conversation and tea time and all of that, because it does take a little while.
Yes,
but
we will chat politely for a moment.
yeah, maybe we should have answered the question.
But
Yeah.
this will also serve to make a point a little bit later when we come to run this process again. So yeah, this is obviously having a good hard think, and it's making the internet grind whilst it goes scanning
Mhm.
through that nearly 900 megabyte image.
Yep. And so this is the SNCC readout of all of the vulnerabilities and issues that they've seen in this container. And as you can see, there's quite a few of them. I mean, they do a good job, and that, maybe that's expected, right? Because it's a big, it's a big image with a lot of different stuff in it. Image magic and all these kinds of different libraries. And they tell you, that they found 341 vulnerabilities, and if you go through, and I don't know why they don't tell you the high severity ones, but if you go through and hand count those, there's 27 that they're flagging specifically, and it took a little while. Now, if we go through and scan the Slim image, so again, not trying to do any magic here, just doing the same thing that we just did. That's going to start running, and
You didn't have to fill the dead air.
Yeah. I know. I was thinking like demo gods are going to be like, this is like not going to complete, or something will happen, right? But no, I mean, it did happen a lot faster. It's a 19 times smaller image, right? So it's much smaller. And here we have no known vulnerabilities and no known vulnerable paths. So we did actually take a lot of stuff out that we just didn't need, right? We don't need image magic in this container. We don't have any images. We're not doing any of that stuff. So so this is a pretty good result for us, and we like that. So that is kind of the net result of the very first container of the week example. That's all I got. I'll say the initial run through of this was much more fraught with challenges and stuff like that. I'll definitely break something next time, but yeah, it's a super simple, basic example, but I think it gives you a little bit of the framework for slimming an image, inspecting an image with X-ray, how we see the web portal working, how you would scan an image for vulnerabilities, what you're looking for. And I think we can take this Flask example and we can start building it out. So I will, I'll give a quick preview. I have if you go to my GitHub repo, you'll find a project called the Scotch Recommender, which was a very bored winter day for me to develop a Scotch recommendation app in Flask that I have since slimmed, and it uses a bunch of cool data science libraries and stuff like that. So I'm going to build that example out. I want to talk about that. Maybe Eric can build it for me in R at some point. So.
Well, yeah, I mean, a common concept in different languages would make for interesting examples. So I'm gonna follow on with this. We've been doing these live on Twitch. We have a YouTube channel. There's lots of good information that Pieter has presented here, but these videos on Twitch only live for a short while before they disappear into the ether. I've been editing down these ever so slightly, and starting next week, we're going to start backfilling our YouTube with the videos we've done here. So there's a link above my head is the Slim.AI website. At the bottom of that website is a link to our YouTube channel. If you get subscribed over there, as we post these videos back up there, you'll be able to use those as sort of a long-term reference for some of the commands that Pieter's run through. I also noticed that Big Pod makes a good point there. He says, one of the problems with public images is that they often aren't updated. Yes, that's definitely an issue. And in fact, again, coming back to Eric and the R and Shiny example, we ran into something similar. And I'm working on an article at the moment which talks about, like, if you're going to publish a container for public, well, not even for public consumption, but if you're going to, publish a container that you expect to be used in anger, then how to pick your starting point with like your Linux distributions, and just highlight some of the unseen gotchas with what your choice might be. And I'll give you a little hint here. Going with a distribution that has commercial sponsorship is probably a good place to start. Right. Well, Peter, that was excellent. Thank you very much for running through that. We're going to be back next week with another example, which may or may not be R. I think it could be. I think that's looking like favorite, but we've got a couple of other ideas as well. So Eric, stay tuned. I'll be in touch, and we'll try and get you involved in that if you're available. And until then, if you're not following here on Twitch, please do, twitch.tv/SlimDevOps. Follow us on Twitter, SlimDevOps there. So Peter, where can people find you?
I am at PSVann, PSVANN on Twitter.
Okay, so if you've got questions about Peter's example, then you can ask him there, and we'll have links to Peter's GitHub if you want to add to that. You can find me on Twitter at m__wimpress, and we are at SlimDevOps on Twitter. So if you've got any questions, you can post them there on Twitter, or again, Slim.AI, at the footer of that, you'll find our Discord, and you can hop in there, and we'll be happy to talk through anything with you there as well. Oh, I see Big Pod's asking more. He's making more comment about like how to make sure containers are updated. Definitely a topic for a future stream, I think, on container updates and best practice.
Yeah, running the apt-get update in there is a good idea. I didn't do this. Do that in this example, but yeah, there's definitely a failure mode there that people talk about a lot, where you like pin an old version or something like that, and then you're not getting any of the updates, and that has a lot of bad negative side effects. So,
indeed. Well, thank you all for coming. Thanks for stopping by. I hope you found that useful. We'll look forward to hearing what your comments are. And if you haven't slimmed a container yet, then do head to DockerSlim on GitHub and give it a try. You may be very happy with the results. So for now, thanks very much. Have a good weekend, everyone, and we'll speak to you soon.
Yeah, thanks, everybody. Appreciate it.
Bye.